So today what we're going to do is we're going to be discussing how to implement multiple linear programming configurations into COMET. Now the reason why this is so important is particularly for areas where you have throughput recovery relationships. So an example of this is where you have a large SAG mill into a flotation plant, the SAG mill being the main bottleneck of the processing, and this is quite common in large copper mines and many other mines. At the end of the SAG mill, you have a grate, and if the grate is quite coarse, then what you have is a lot of material can flow through the grate into the rest of the processing, but because it's quite coarse, you don't get a very good recovery. If you have a finer mesh on that grate, then you end up with a greater recirculating load back through the SAG mill, and that tends to make everything finer and give you a better recovery, but you have less material in total going through the SAG mill. Another example of a throughput recovery relationship is when you have leaching. So with leaching, the time that you spend leaching a product will determine the recovery. So if you have something for 30 days that's leaching, then and you get a 80% recovery, then after 60 days you might get a 90% recovery, or after 20 days you might get a 60% recovery. And so you've got this ability to trade off how much throughput you get with what recovery you get. So they're actually quite common in the mining industry, and one of the really interesting things is that they're not well exploited in the industry because you need to combine the mining engineering schedule in with the processing plant processing options. And sometimes this falls between the gap of the disciplines. So I'd like to show you now how we can implement this with a new capability that we've added to COMET recently. So let's first look at the phase files. We have 3 new targets. So in addition to the standard ore that's being used to collect all the material that's being processed, we have now a low, a base case, and a high ore target. So the idea of this is the low one is going to have a lower throughput, but a high recovery, actually another 5% recovery for that material. The base case will use our existing recoveries that have been brought into the attributes through the phase files. And then the high one, actually we're going to lose 5% recovery, but we're going to allow more material into this process. Now, the next thing that we're going to look at is in the cash flow. What we do is we've changed from this variable cut-off grade here into a custom cut-off grade. And one of the differences you'll note here is that the custom cut-off grade, instead of just being a linear program and specifying the scenario, we can specify a number of scenarios here, just with a comma in between each one of them. And then what we have now in this setup is 4 different scenarios: a base case scenario, a high scenario, a low scenario, and a dual scenario where both base case material and high grade material is processed at the same time, just for an example. Now, it's the linear program that's going to put material into these high, base case, and low targets. And so once they've been added to the targets, we're going to add them to ore. And because we have different recoveries in each of these processing routes, we're going to correct the copper and gold recovery here. So now let's have a look at the linear programming setups for this. So the first one I'd like you to look at is the base case scenario. So in the base case, we have a product that's sending material to ore base, and that has got some constraints, some costs, some revenues for the different products. And then what I'd like you to notice is the similarity between the base scenario and the low scenario and the high scenario. They're set up virtually exactly the same, except the recoveries are 5% higher in the low throughput scenario, and our capacity of the low throughput scenario is only 60% of the base case capacity. Likewise, in the high throughput scenario, we have a capacity of 130% of the base case scenario, but we lose 5% of the recovery of both the copper and the gold. And then the last scenario, we have this dual scenario, which sends material to our ore base target and our high throughput target. So the base one is set up quite similar to this one, but we only have 95% of the capacity being used by the base processing route. And then we have another 10% of the capacity able to be used by the high throughput scenario. So it's a combination between the two. So you could actually have material going to both scenarios. The costs and prices for recovered material are all equivalent for each of these different material going to the different streams. Okay, now the last thing that I'd like to look at is in the reporting, because when we actually generate one of these scenarios, so what's going to happen is in every period, COMET's going to go through the low, the base, the high, and the dual scenario, pick which one makes you the most money, and use that for the period. So there'll only be one scenario used in each period, but every period you can actually have a different scenario that's picked. So because of that, we're going to want to know which scenario was picked in each period. So if we look at our period formats, you can see there's a new stream type of information called LP scenario name. So you can see that in the list, and that will tell us which of the scenarios have been picked in each period. So let's run this. Now, running this, I've only set it up for one iteration just to give you an example of what this looks like. But what's going to happen is COMET's going to go through as the different rocks change as you go through the mining of each of the phases, so that grade distributions change, the capacities change, the sinking rates change. COMET's going to be looking for what processing scenario makes the most money in each of the periods, and then considering at the same time as that the remaining value, the estimate of the remaining value that the standard COMET algorithm is using to make these decisions as to what to mine. And so at the end of each period, we will have selected one processing configuration in each period, and that processing configuration can change over time. So let's look at the period schedule. So what we can see for a start up here is which scenario was chosen in each period. So you can see we're using the low throughput scenario in the first year. We've swapped to the dual for the next couple of years, then to the high. Eventually we're using the base, back to the low. And so this is changing as the material changes over the life of the project. If you look down at how much material actually went to each process, you can see when we're using the low throughput scenario, we only have material being added to ore from the low target. When we use the dual, we've actually got base and high, and so on. You've got only high here, only the base here. So this is showing you over time, this is being adjusted to make a little bit more money. Now, if we want to know in more detail exactly what material has been sent to each target, then we can go to the linear programming solutions. So if we go to the LP solutions tab, what we see here is in the first period, we only had the low scenario being used, and so you can see which cut-off grade bin went to the low target and how much of it went there. So we had right from the highest cut-off grades right down to cut-off grade bin 20, which represented a cut-off grade of about 3.6. That material all went to the low throughput, high recovery process. Then in the second year, we actually had the dual process being used. So we had some material going to base, and you can see each cut-off grade bin, how much went to that process, and then for the high grade, for the high processing stream, high throughput processing stream, you can see which material was used to go there too. So what you can see here is that it's quite easy to implement a number of different configurations of your processing plant and have them evaluated and optimized during the life of the project. And so that each period you'll have another configuration that's picked that makes you the most money. One of the interesting aspects about this and the additional capability is that instead of making one large complex scenario with a number of different products being produced, you can make several smaller linear programming scenarios with simpler configurations of your processing plant. This can help both for speed, but also for making your plans more practical, because only one configuration is chosen each year. You don't have to get into things like batching some material through a high-grade process, some material through a low-grade process, and so on. So it's normally a lot more practical. We can see this particularly being useful for the throughput recovery relationships, but there might be others. So I'll be looking forward to seeing how you apply this. Until next time.